A current I is flowing through it. Okay, there's a magnetic field, we'll bring it. B bar equal to 2I cap minus 3J cap plus 4 cap. I'll switch on. So I want and let the current be 10 ampere. We have to find out the net force on the loop, dipole moment, and the net torque. Find net force, dipole moment, and net torque on the loop. Is it a what you can do here now? You look at the different parts of the segment. Different parts of the segment of the loop are lying in a different plane. So therefore, what has to be done? So I should assume an equal and opposite current elements. So let's bring current element here. Okay, I think this will be enough, no? So a complete loop is formed. So here is what we have, one loop. Hope everyone is able to understand. So what do you mean by that? Loop is what I'm reflecting through this shaded diagram. Now get into the calculation part. Equal and opposite current elements are introduced. So now from there, calculate the dipole momentum of individual loops lying in different planes. Then take the vector sum. Can you assume any number of elements as any number of, but minimum number of current elements are to be assumed. That's the one rule is what I have put it. So everything what happened, what all that rule is there, is it practically satisfies or not? I think that matters a lot. Okay, now the current here. So current here will be in this direction. Current here, the equal and opposite current elements, when you bring it, will be of this kind. So now 1, 2, 3. This was a 4, 5, 6, 7, 8. Define dipole moment, net dipole moment of the loop. Let me write it in this way: M234 bar plus M374 plus M145. M1234. Okay, there's a loop of side length 10 centimeters. I'll give it 0.1 into 0. Okay, this will be M45. Where is M45? Off of it. Yeah, we'll get in. Now, what is M1234? This should be equal to current I into 10 centimeter, 100 centimeter. 100 centimeter will be 1 meter. So therefore, this will become only 1 into what is the direction? Direction of this should be I cap. M374. M374 should be J cap. I into this will be 1 by 2. J cap. 145 will be I into 1 by 2 square meter K cap. Okay, we know current I is equal to how much? 10 ampere. 10 I cap plus 5 J cap plus 5 K cap. This is M bar. Okay, once you know M bar, rest all other things. What about the net force? First net force should be 0, no? How I'm writing directly? Because you know that if a current carrying loop kept in a uniform magnetic field, the net force should be 0. Dipole moment, we got it. What about the torque? Torque, I'll go for M bar cross B bar. B bar, 2I cap minus 3J cap plus 4K cap. I cross I will be 0. I cross J will be K. So this will be minus 30K cap. I cross K will be minus J, minus 40J cap. 5 into, so this will be J cross I will be minus K, minus 10K cap. 5 4 jar 20, J cross K will be I, 20 I cap. K cross I will be J, 10 J cap. K cross J cross K will be I. K cross J will be minus I. So this will be 15 I cap. 35 I cap minus 30 J cap minus 40 K cap. So this will be the net torque acting on the loop. Will it rotate? Yes. What is the axis of rotation? This one. No, don't bring M bar. Try to calculate force on each arm and try to predict this axis. Not possible. Nobody can do this. It may take 1 day or 2 days. Trial and error, that too we have to try and search everything. So what do this? This will give the unit vector. The unit vector will give the axis of rotation about which this loop will rotate. Hope you are able to understand. So how to calculate the unit vector about which it will rotate? N cap equal to tau bar by mod of tau bar. Mod of tau bar. So this will be 35 square, 30 square, 40 square. Calculate this then vector. So what is this unit vector? Unit vector along which the torque acting on loop is directed. Okay. So therefore that whenever the loops are incomplete, so what you can do, you can assume equivalent opposite current element and make it some complete loop in a given plane, then define dipole moment in individual plane, then net dipole moment, vector sum of dipole moment of the individual planes. I think this is the one method. Remember, very easy. Anything numerical related to this will come, you can manage in the exam. Okay, make observation. I'll go for the next problem. This we have completed. Yeah, there's one more very good information based. Already, it's some. I'll read it. A ring of mass m, radius r, carrying current I, is lying in XY plane.